Hi, this is Mrs. Slater, and we are going to work with quadratic equations by using substitution. So basically, you're going to see some weird equations that you can transfer back into quadratic equation and be able to solve it a lot quicker than another method. So here we go. Let's start with the steps. The first step is you're going to let u equal, and it's always going to be the middle term minus the coefficient. Next, you're going to solve the equation for u. Okay? And then substitute the u value. And finally, solve for x. So go ahead and push pause if you need some more time to write that down. Now, I do want to add, you're always going to check for extraneous solutions. That never goes away with these type of problems or any kind of quadratics. So in example 1, off to the side, we're going to let u equal the middle term minus the coefficient, which would be the square root of x. Now, if we squared both of these, if you squared this side and squared x squared square root of x, you end up with u squared equals x. Okay, so what ends up happening is we take this information and replace what we now know the value to be. U squared, and then this one is going to replace with u, and all the coefficients are going to stay the same, and the constants. Okay, now we try to find factors of 10, and we know that to be 5 and 2. We would need to have a positive on the 5 and a negative on the 2. That will happen to you sometimes. You're just so used to using x, but keep with 2. I'm sorry, with the u in this particular case. And now, after we have solved for u, we end up with negative 5 and 2, which is good because they're nice integer numbers. And then I usually like to write them both out again. Okay, so think about this. The directions say to solve for x. Now, when we are at this step, we are not done. We have to do one more thing. And because we are solving for x, we are going to replace what we know to be true. U equals square root of x. So I'm bringing the square root of x back and setting that equal to a negative 5. And I'm going to bring it back in this second one as well. And then just becomes a solve for x problem, where you're going to square both sides, and you end up with x equaling 25 and x equaling 4. Okay, and as always, you want to check for extraneous solutions. So if I take the 25 and replace 25 everywhere I see an x, would look like this. So 25 plus 3 times square root of 25 minus 10 is supposed to equal 0. That's what we're trying to check. So 25 plus, that's 5, so that's 15. And as you can see, 40 minus 10 does not give you 0. So this is considered an extraneous solution. I still want you to find it and then just cross it out at the end. Let's go ahead and check the next one. Everywhere I see an x, now I'm going to put a 4 in that spot. So 4 plus 3 root 4 minus 10. 4 plus 3 times 2 is 6. And I end up with 10 minus 10, which then is 0. So that is going to be your answer for the first example. All right, in example number 2, we are going to let u equal the middle term minus the coefficient. So that's going to be x squared in this case. And if I square both sides, u squared is going to be equal to x to the 4th. All right, now let u substitution. X to the 4th is u squared. X squared is u. And now we're going to solve the quadratic. It does factor nicely into 9 and 1, u and u minus and minus. All right, now zero product property says that my two answers are 1 and 9. And again, like last one, I'm going to separate them and bring what we already know to be true. So here is supposed to be an x squared. Also here is supposed to be an x squared. And if I'm going to solve for x, I'm going to end up with x equals plus or minus 1. x equals plus or minus 3. Again, we are dealing with an x value, so you are going to have to consider both the plus or minus in each. So if you're going to check your answer, the original problem, x to the 4th minus 10x squared plus 9 equals 0. Put in a 1 everywhere you see an x. So that would be 1 to the 4th, 10, and then 1. So you have 1 minus 10, and that indeed equals 0. So that one's good. And then a negative 1, if I put a negative in both those places, the even exponent is going to guarantee I'm going to get the same exact answer. So those 1 and negative 1 both work. Okay, and then for the next one, if I put a 3 in that spot, you end up with 3, so that's 9, that's 81, 60. Okay, and then with the final answer, oops, I just realized I have made an error. This should be 90 because 10 times 9. Let's go ahead and put a 90 there, and then you end up with 0 and 0. So positive 3 works. And again, if I put a negative in here, that 4 and that 2 exponent are going to guarantee that I'm going to get the exact same thing. So all 4 of those answers are going to work. All right, so let's go on to the third one. Again, the level of difficulty just a little more intense, but the steps remain the same. Let u equal the middle term minus the coefficient. And then u squared, if I square both sides, would look like this. Okay, now in this particular problem, the squared is missing, but it is on your packet, so I'm not too worried about that. And then if you replace this with u squared, replace this with u, you end up with a trinomial that can factor. So go ahead and push pause and do so. Okay, so you should get u minus 10 and u minus 5. And in this case, u equals 10 and u equals 5. Okay, so this is where we're going to bring back what we let u equal in the first place. So u is now x squared plus 1 equals 10, and u is now going to x squared plus 1 equals 5. To solve for x, we get plus or minus 3. And when you solve for x, you get plus or minus 2. And then don't forget to check your work. And then in class, we will go over if those work or not. So check your answers for class. Number 4, let u equal t to the 1/3. So then when you square both sides, t is going to be to the 2/3, which is a match. U squared minus 3u minus 10 equals 0. Go ahead and solve for u and push pause to do so. All right, so hopefully you have factors of u minus 5 and u plus 2, and then u equals 5 and u equals negative 2. Bring back the 1/3, t to the 1/3 I mean, and then we're going to cube both sides. So little side note here. If you have t to the 1/3, another way to write that is cube root of t, right? So if it's cube root of t that you have on this side, what does that mean you can do to both sides? Well, that means you can cube both sides. So why not save the step and just go right to cubing both sides? Because 1/3 times 3 is 1, and that's what we need. So again, I just wanted to show you that so you knew where it was coming from, and it's definitely something you've done already, just not in exponent form. Okay, again, cube, cube. So we end up with t equals 125, I believe. Yes, indeed. And then t equals a negative 8. Okay, now we want to check your answers to see if you found any extraneous solution. And then we'll go over what you found out in class tomorrow. Number 5, let u equal the middle term minus the coefficient. So x to the negative 1. and then u squared. If I square both, I'd get x to the negative 2. So this ends up being u squared. This one is u minus 6. Go ahead and push pause and factor and solve and go ahead and substitute everything back in. So if you did everything correctly, it should come out to looking like this. And how do you solve it when it's to the negative 1? Well, we know that anything to the negative 1, to get rid of those negative powers, is going to be 1 over x. Same with the second one. And then we can just cross multiply. So this would be over 1, this one would be over 1, and then 3x would equal to 1. X is going to equal 1/3. And then on the second one, cross multiply. Negative 2x equals 1. X equals a negative 1/2. And again, check for extraneous solutions here to see if they both work. And then finally, we have another type of problem where let u equal 5th root of t. See that right there? And then u squared, if I squared both, it would be the 5th root of t squared. Okay, and by substituting it in, you know what to do next. And I want you to finish all this for class. See if you can get negative 3,125 and 243 as your values of t. All right, good luck, and that concludes today's lesson.